My name is Ilsa Cooke. I'm a new assistant professor in the Department of Chemistry here at UBC. So astrochemistry is the study of molecules in space. So basically what we're trying to do is understand which molecules are there in space, how they got there, and why they're there, and then how they're transported through the sequence of star formation, so how they end up in new solar systems. And the reason for this is really approaching questions of the origins of life, so life on our planet as we know it. So we want to look into other regions of space and see if we can detect molecules like those that we have on Earth that we call prebiotic molecules. So we're interested to kind of use our tools like radio astronomy to look into the sky and search for these fundamental building blocks of life. Because if we can detect these in regions of space, they potentially could be incorporated into new solar systems. So we know that maybe life could then evolve in other planets and not just in our own planet. Radio astronomy is really the greatest tool that we have in astrochemistry. And what it really involves is detecting radio wavelengths. So something like when you have your stereo and you're tuning to listen to a radio station. And we use those to be able to detect rotations of molecules. So molecules in space rotate around, and we detect these very weak signals coming from hundreds to thousands of light years away. And basically it starts with these molecular clouds. So the very earliest stages of star formation, we have these big clouds of gas and dust, and these start to collapse under the influence of their own gravity, and they start to form these very dense regions in space. Now these regions then start to warm up, and we start to have very complex chemical reactions that can occur as the temperature is raised. And then slowly they come together and they form protostars. So these are the very, very early stages of stars like our own sun that eventually will hopefully harbour planets and be new solar systems.